everybody. I'm going to go over the review for Conic sections for our unit test next week. I'm going to work on the calculator section first, and I'm going to encourage you with all of these problems to always draw a picture to help understand the information that's presented. In the first problem, you're given 3 different scenarios, and you're basically asked to come up with the equation for the parabola given the characteristics. Most of the problems on the unit test are going to be in some context. So make sure that you read into the problem and draw a picture so you can understand what part of the information is referring to the vertex or the focal length and so forth. In this case, in part A, we have a parabola that has a focus at -2, +3. It opens down and has a focal length. Notice that it says it's the absolute value of P is equal to 2. And that's only to give it so that you have to determine whether or not P is positive or P is negative. So because we know that this graph opens down, that should be an indication to us that the value of P is actually -2. So I'm going to sketch a picture. I'm told that the focus is at -2, +3. So that's my focus. I know that the graph opens down. And remember that the focus is inside the parabola. So I've got to figure out where the vertex is. In this case, since the parabola opens down, the vertex must be above it. And when you think about how far above it, it's got to be 2 units away because our focal length is a -2. So my vertex, if I think, now that I have a picture, it makes it a little bit easier to see. I know that the x-coordinate of my vertex must be -2. And so since my focus was at +3 for y, and I had to go up 2 more units, that means that the y value of my vertex is 5. So that gives me h and k. I know now that h is -2 and k is 5. Now, since this is a vertical parabola, I know it's going to be of the form where y is equal to x squared. I just have to remember all my transformations. So remember, if it's of the form y, it would look like this. Y minus k is equal to 1/4p times x minus h, the quantity squared. And if it's, so this would be if it's a vertical parabola. If it's a horizontal parabola, it would be of the form x minus h is equal to 1/4p times y minus k, the quantity squared. I do also want to point out, while we're talking in general terms, that the 4p can be on either side of the equation. However, if I were to rewrite it, for example, with the vertical parabola, when I multiply both sides by 4p, I would see that 4p times y minus k is equal to x minus h, the quantity squared. So when you're presented with an equation, as we will see later on, you want to see where the coefficient, on which side of the equation the coefficient is. If it's on the squared side, then the coefficient is going to be 1/4p. If it's on the other side, then it's just going to be equivalent to 4p. Okay, getting back to our equation. Since we know that this is a vertical parabola, I'm going to be using this form of the equation. And so I'm just going to fill in what I know. I know I'm always going to have an x and a y, so I'm going to have y minus the value of k, which is 5, and that's going to equal 1/4 times the value of p, which we decided was -2. And then I'm going to multiply x minus h. Since h is -2, I'm actually going to do x plus 2, the quantity squared. The only other thing you really want to do is just adjust that coefficient. Remember, the coefficient is the number in front. So my equation becomes y minus 5 is equal to -1/8 times x plus 2, the quantity squared. In part B, it says the parabola has a vertex at 0,6 and a focus at 0,8. Again, I'm going to draw a picture. So if my focus is at 0,6, that means, my vertex is at 0,6 and my focus is above it at 0,8, that means that my parabola, remember that obviously the vertex is at the vertex, but the parabola is always going to wrap around the focus. So in this case, this parabola must open up. So I know the value of hk, that's my vertex, so h is 0 and k is 6. Since my graph is opening up, I know that I'm going to be dealing with, again, this vertical parabola, so I'm going to be dealing with that form of the equation, and I know that p must be positive. So I just got to think about the distance between my vertex and my focus. Well, if my vertex occurred at 0,6 and my focus was at 0,8, I know that I have a p-value of 2. And so that gives me the other piece of information that I need to write my equation. So again, I just fill it out. Y minus k, in this case, I'm going to do y minus 6, is equal to 1/4 times p, which we discovered is 2, times x minus h, the quantity squared. And when I simplify that, I'm running out of room, but I'll simplify it over here. I get y minus 6 is equal to 1/8, and x minus 0 is just x squared. Okay, if you want to write it in the other form where we add 6 to both sides, this would be equivalent to y equals 1/8 times x squared plus 6. Both of these mean the same thing, and it doesn't matter to me how you write it. A lot of the problems on the test are multiple choice, or some of them are anyway, so you just have to recognize the different forms of the equation. And then in letter C, we know we have a vertex at -4, 3. So there's my vertex, and we know we have a directrix at x equals -2. Remember, if it's x equals -2, that means it's a vertical line, and so x equals -2 is actually going to look like this. So if I think about the direction of my parabola, remember the parabola can never touch the directrix. That means my parabola must be opening in that direction. That means that my p-value is negative. And if I think about how far my vertex is from the directrix, I know that it's 2 units away. And so since my focus has to be on the inside of the parabola, I know that p is -2. We're given the vertex, so I also know that h is -4 and k is 3. So now, again, I'm going to write the equation, but this time I have to pay attention to the fact that this is a horizontal parabola. So this time I want to use this form of the equation, where it's going to be x minus h, but since h is negative, I'm going to end up writing x plus 4 is equal to 1/4p. We said p was -2, and then we'll multiply times y minus k. So y minus 3, the quantity squared. And I'll simplify this to x plus 4 is equal to 1/8. Actually, it's -1/8. And that's going to be y minus 3, the quantity squared. Okay. In number 2, it says, suppose you were given the equation -4 times the quantity y minus 2 is equal to the quantity x plus 2 squared. You need to be very careful with this form of the equation, because we're used to having the coefficient on the side of the equation where x is squared, or where y is squared. When the -4 or when a coefficient is on the other side, you've got to remember that it's a different form of the equation. So if I wanted to adjust it to look like all the other equations, I could multiply by 1/-4, or I could simply divide both sides by -4. And so that gives me a different equation. It's going to look like y minus 2 is equal to -1/4 times x plus 2, the quantity squared. Okay, and so that is the form that we're more comfortable with. But it doesn't matter. It doesn't matter if you want to look at it as the -4. Just remember, if you're looking at it in the original form, then this quantity is actually equal to 4p. When the coefficient is on the side of the equation that involves the x squared, for example that, it's going to be equal to 1/4p. And it really doesn't matter how you look at it, you just have to recognize which side of the equation it's on. So if I want to determine the value of p, I can cross multiply. So I'm going to have -4p is equal to 4, so p is equal to -1. All right, I can tell in this equation, since the x term is being squared, that this is a vertical parabola. And since p is -1, I know it has to open down. The vertex, remember this is your hk, so I'm going to determine h. Remember the h value is always associated with x. And so my h value is I'm going to look to that set of parentheses, and it's always going to be opposite. So h is -2, and then k is the value that's always associated with y. In this case, since I have y minus 2, it tells me that k is equal to 2. That means that my vertex is at -2, +2. I'm going to go ahead and plot that point. I'm going to label it as my vertex. Now it's asking about my focus. The easiest thing to do here is to now use my focal length, which is -1, and plot the point of my focus. So rather than using formulas, notice I haven't referred to any of the formulas. You'll have them available, but if you draw a picture, it'll help explain the situation better than the formulas will. Since p is -1, I know my focus has to be 1 unit below my vertex. So my parabola is going to look like this. And if I look at my graph, I can see that the coordinates of my vertex are -2, +1. The directrix then has to be on the other side of my vertex. And remember, your directrix is going to sort of be of the same form as your equation. So if it's a y equals equation, your directrix is going to be y equals. And if I look at my graph, I can see very clearly that y has to be 3. And we already sketched the graph. So I suggest doing the sketch as a first step rather than the last step. Okay, number 3, this is where we start getting into some applications. In number 3, it says the figure below shows a parabola with a vertex at the origin. So this is important. We know that this is at 0, 0. And it says the distance between the directrix and the focus is 4. Now, be careful of that. That's the distance between the directrix and the focus, not our focal length. Remember, our focal length is the distance between the vertex and the focus. That means our focal length, and I'm going to call it P, has to be 2. Since this graph is opening up, I know P is going to be positive. So it asks for the equation of the parabola. This is one of the ones that's pretty easy because I haven't shifted the graph at all. Since it's vertical, I know it's going to be of the form y equals 1 over 4p times x squared. And since I know what p is, I know that y is equal to 1 over, if I multiply 4 times 2, I get 8x squared. Now here's where it gets a little tricky. Now it's asking me to find the distance between points A and B. Well, again, looking at the picture is helpful. I know that this height right here is 2. So I know the y value of each of those coordinates. I just don't know the x value. So I'm going to take a look at point B, and I'm going to call it x, comma 2, because I don't know the x value, but I do know that it's 2 units above the x-axis. So what I'm actually going to do is plug in what I know for y. So I know the y value of point B. I know it's 2. So I'm going to use my I'm going to use this as a formula to solve for x. When I let y equal 2, I get 2 is equal to 1 over 8 x squared. If I multiply both sides by 8, I get that 16 is equal to x squared. And if I take the square root of both sides, I get that x is either positive or negative 4. So that gives me the x value of these 2 points. So point B must be at positive 4, 2, and point A must be at negative 4, 2. And we're asked to be very careful about what the question is asking. It's asking, what is the distance between point A and point B? Well, if this is positive 4 on the x-axis and this is negative 4 on the x-axis, then the distance between them is 8. Okay, so this is an application. All right, number 4, it says a cross-section of a solar reflector is the shape of a parabola. Suppose the parabola, or the reflector, is 16 feet wide and 8 feet deep at the center. Now, please recognize that 8 feet deep, that is not telling you the focal length. It's telling you the depth of the solar reflector, so we don't know where the focus is at this point. What I do know is that this distance here is 16, and the height here is 8. So that information alone enables me to find these values. So if I know that the whole distance is 16, this value must be positive 8, and this value must be negative 8. And I also have the y value because I know the depth of my reflector is 8. That means the coordinates of this point are positive 8, and the coordinates of this point are negative 8, positive 8. That still doesn't tell me my focus, but I can use one of the ordered pairs to help me determine the equation for my graph. So we know that my vertex is at 0, 0. I know that the graph opens up. So if I think about the general form of the equation, it's y equals 1 over 4p times x squared. So what I'm going to do is I'm actually going to use one of my ordered pairs, and I'm going to let x equal 8 and y equal 8, and I'm going to use those values to solve for p. That means that 8 is equal to 1 over 4p times 8 squared. If I simplify it, I get that 8 is equal to 64 over 4p. And 64 divided by 4 is 16, so 8 is equal to 16 over p. If I cross multiply, I get 8p is equal to 16, so p is equal to 2. So now, if I know the value of my focal length is 2, that means my focus has to be there. It's positive, so I know it's going to be above my vertex, and I can see that my focus then is going to have an x value of 0 and a y value of 2. And it asks me, what is the difference between the height of the focus and the depth of the dish? So I know my focus is here at 2. And if I'm looking for the difference between the height and my focus, I'm looking for that distance there, which is going to be 8 minus 2, or simply 6. And I think it's in feet. Okay, so that is it for the calculator section. I will create another video tutorial for the non-calculator section, and I will post that separately.